Hello everyone, today is December 27 and it's time to open a new problem for our coding advent calendar from LeetCode. Let's see what the problem is about. Here is a problem for today. Maximum bags with full capacity of rocks. You're given n bags numbered from 0 to n-1. You're given two zero-indexed integer arrays, capacity and rocks. The I bag can hold a maximum of capacity of I rocks and currently contains rocks I rocks. You are also given an integer additional rocks, the number of additional rocks you can place in any of the bag. Return the maximum number of bags that could have full capacity after placing all additional rocks in some bags. Okay, here is an example. 2, 3, 4, 5, it's our capacity. It's filled like 1, 2, 4, 4. That means that third bag is full already, and for all the rest we have only one additional space, and we have two additional rocks. That means we can have output equal to 3 because we can place these additional rocks in any buckets, and as a result we are going to have 3 full bags. Another example, capacity 10 to 2, and we have fulfillment like 2 to 0, and we have 100 additional rocks, and we can fill all the bags with additional rocks. That means the output should be 3. Okay, so this problem marked as medium, and it appeared at Amazon interviews last year, like year ago, but actually there is nothing complicated in this problem. All we need to do is to calculate the number of vacancies in all the bags, and then try to fill these vacancies with additional rocks. To do this in an efficient way, we need to sort this array of vacancies in an ascending order, and we will just fill these bags with additional rocks until we get rid of all additional rocks. Then we just need to take the current index of sorted array for additional vacancies, and that will be our answer. Okay, let's do this. So var n equal to capacity length. Let's arrange our array of vacancies. And let's calculate vacancies based on capacity array and rocks array. Okay, this is done, and now we just need to sort this array. Okay, What are we going to do now? Let's do it this way. Let's create an additional variable called result, set it to 0, and do for loop and if we are out of additional rocks, that means the number of vacant places in current position in current bag is more than additional rocks we have, we need to return the result because we cannot fill this bag. If vacancies I minus additional rocks is more than 0. Okay. Extra if here. Return result. If it's not, if additional rocks is more than current vacancies, current number of vacant places in the bag, then we need to fill it. Let's mark this bag as filled, and let's add 1 to our result. And let's take number of vacant places from the number additional rocks. Okay, that's it. In the end of the loop, we will either we will have lack of additional rocks, and then we will return a result from inside of a loop, or we will finish the loop until the end of number of our bags, and we will return result from the end of our algorithm. Let's run it. Okay, both cases from examples are passed and accepted. Let's submit our solution, and it says that our solution beats 100% of all submitted solutions and beats almost 30% in memory consumption. Let's estimate the complexity of our algorithm. The most complicated part here, the most time consuming part, is sort, which is big O of n log n. All the rest are linear time parts, so the time complexity of our algorithm will be big O of n log n. And we create additional array of length n. That means we use big O of n additional memory. That's it. This problem was not hard at all. The only thing you should keep in mind is the time complexity of built-in operations like sort. I know what you're going to say. There are different sorting algorithms and they have different characteristics. And I say yes, it is. But most likely the standard library have few implementations inside and switches between them based on heuristics. I would expect it switches between quicksort and merge sort, but you can correct me if I'm wrong in comments. See you tomorrow.